गुड मॉर्निंग मैम।
गुड मॉर्निंग। कौन बात कर रहे हैं?
एलिया मैम।
क्या हाल है एलिया?
यस मैम, ठीक। मैम हाउ आर यू? मैम हम कह रहे थे कि मेरा ना, मैंने आपको मेल किया था कि मेरा रोल नंबर नहीं वो उस लिस्ट में आया, वो
हाँ
मिड टर्म
ठीक है,
एग्जाम।
मैंने आपको वो टाइम दिया है ना एलिया?
2 बजे का थर्सडे।
हाँ
यस मैम।
ठीक है,
यस मैम।
ठीक। हेलो निम्रा।
Assalamu alaikum, ma'am.
वालेकुम सलाम। हाउ आर यू?
I'm good. How are you?
आई एम गुड, थैंक यू। हेलो महनूर।
Assalamu alaikum, ma'am.
वालेकुम सलाम। हाउ आर यू?
I'm good, ma'am. How are you?
I'm fine, thank you. Halima doesn't seem to have a mic. Okay. Right. Okay, let's start. What were we talking about last time? Do you remember? Okay, yes, who would like to tell us? What were we talking about last time?
मैम ग्राफ्स के बारे में पढ़ा था हमने।
ये बेटा नाम भी बताया करो ना। कौन बोल रहे हैं?
मैम नेम एग्जैक्टली याद नहीं है मुझे।
अच्छा ठीक है एलिया। एलिया आपका नाम पूछ रही थी मैं। अच्छा, yes, we talked about graphs. Yes, this is important. What kind of graphs did we talk about?
मैम स्केलर और वेक्टर क्वांटिटीज को हमने डिस्कस किया था लास्ट टाइम। और इनिशियल
बेटा नाम बताओ अपना। आमना। हाँ आमना बताओ।
मैम स्केलर क्वांटिटीज और वेक्टर क्वांटिटीज को हम डिस्कस कर रहे थे। टाइम, डिस्प्लेसमेंट, वेलोसिटी, ये सारी चीजें।
Okay. Yes. Anyone else? We talked about graphs. Elia just told us what kind of graphs. Can somebody remember? This is important actually. Yes. किसको याद है? इसका मतलब आपने पढ़ा नहीं घर जाके, हाँ? You did not study. So we talked about position time graphs. These are also known as displacement time graphs. And we talked about velocity time graphs. In all of these graphs, you have, for the position time graphs, you have along x-axis the time and along y-axis the position x, which can be then the displacement also, right? When you do displacement is defined as s is equal to x2 minus x1, and this is t. And similarly, velocity time graph is a graph in which you have time along x-axis and you have velocity along y-axis, right? Again, we talked about area under the graph. Area under the velocity time graph gives what? We also talked about the slope of the graph. So the slope of the position time graph gives you the velocity, for example. The slope of the velocity time graph will give you what? So these are questions you have to keep in mind in order to understand the concepts that we are covering in this chapter, okay? So we continue from where we left last time. Okay, so here you can see we have, look, you can see the book, right? You can see this figure. This is uniform acceleration in one dimension. So these are graphs. What you can see here, this is displacement time graph, okay? So just try to understand the differences in this case. Okay, so displacement time graph, you have velocity time graph, you have acceleration time graph, okay? Here, all these three graphs have been drawn for uniform velocity, uniform or constant velocity, when the velocity of a body is not changing. It does not mean that the body is not moving. The body is moving, but it's moving with the same velocity. For example, if you're driving your car, you're driving it at, let's say, 20 kilometers per hour, then it means for, let's say, 1 hour, then the velocity was constant, but the body was moving. So this means that the position of the body was changing, the displacement was changing with respect to time in a linear way. So when you have a straight line like this, it means that the change in displacement is proportional to the change in time. This means that the velocity is uniform or constant. So if you have to learn how to understand and interpret these graphs, because you will get problems about these graphs. So when you see here, you can see if you take the slope, if you have this graph and you're asked to find the velocity, you can just take the slope of this line. So this will be x2 minus y2 minus y1 divided by x2 minus x1. That will be the slope, which will be equal to the velocity. You can remember this by saying that velocity is equal to the change in displacement divided by change in time, so which is the slope. Okay, so this is the change in displacement is y2 minus y1, and the change in time is x2 minus x1. Okay, please pay attention to these graphs, try to understand them. I'm going to take your attendance. Okay, okay. So Ahmad Hassan, absent. Ahmad Fahad bin Ahmad, absent. Aisha, absent. Musa Ali Musa, absent. Mahnur,
Present, ma'am.
Nimra,
Present, ma'am.
Sayyid Azad Asad, Farooq Ahmad Farooq, Awais Khabar Gil, Laiba, Sahib Khan, Elia Shafqat.
Yes, ma'am. Present, ma'am.
Okay, good. Amna Maham,
Present, ma'am.
Nashra Rashid,
Present, ma'am.
Aruba Riaz, Halima Ijaz,
Present, ma'am.
Nawab Siddiq, Sumavi Tahir, and Saul Rafaqat.
Present, ma'am.
Good. Okay.
मैम आज काफी बच्चों का इंटरनेट इश्यूज होगा, इस वजह से नहीं आए होंगे.
Maybe, yes. Okay. Anyway, we will upload the recording also so they can watch that. Okay. So I was talking about these graphs, and in this case, if you have a constant or a uniform velocity, if it has to be represented in a displacement time graph, you will see a linear line. Okay, if you represent it with in a velocity time graph, you will see a straight line. Straight line means the value remains the same over time. If this is like 1 second, 2 second, 3 second, whatever, the value is remaining the same. If you look at acceleration, acceleration is defined as change in velocity divided by change in time. So change in velocity, if the velocity is the same, it was 20 kilometers per hour in the beginning, it's 20 kilometers per hour later on. So the change in velocity is 0. So it means the acceleration is 0. And acceleration is 0, you can see this thick line, which is, this is the origin, this is the x-axis, this is the y-axis. You can see the thick line along the origin horizontally represents the acceleration is equal to 0. So this is an explanation. If you have a horizontal line on the displacement time graph, what does this mean? A horizontal line like this on a displacement time graph means, I'll give you a point for this, yes. Yes.
Ma'am, no change in direction if it is displacement.
बेटा ये हमने लास्ट क्लास में पढ़ा था, ये आपको पता होना चाहिए. अगर स्ट्रेट लाइन आती है इन अ पोजीशन टाइम ग्राफ, व्हाट डज इट मीन? ओके, आई लीव दिस. हाँ,
डायरेक्शन कांस्टेंट है, वो चेंज नहीं हुई.
नहीं, इसके अलावा डायरेक्शन कांस्टेंट के अलावा, डायरेक्शन कांस्टेंट जरूरी नहीं है, लेकिन बट एनीवे ओके. अब लेकिन नहीं, इसका एक मेजर मतलब ये नहीं है. इसका मेजर मतलब क्या है? इसका मेजर मतलब ये है कि द वेलोसिटी ऑफ द बॉडी इज 0, and that means that the body is not moving, it is stationary, because in this is the position time graph. Okay, position time graph, this means the slope is 0 in this case, and if the slope is 0, it means the velocity is 0, it means the body is not moving at all. So this is what it means. Now the second set of 3 graphs again represents uniform acceleration. Uniform acceleration means the velocity is changing but at a constant rate. The change in velocity is the same, it is changing but by the same amount after equal intervals of time. So if you make a displacement time graph, you will see that you will get a curved line. If you make a velocity time graph, you will see a line, a linear line. This means that this is the slope. The slope in a velocity time graph gives the acceleration. So you will see that the slope is the same at different parts of the motion, and therefore the acceleration is the same. The velocity is not the same. The velocity is increasing. So you can see the slope in the case of the position time graph gives the velocity. The slope in the case of the velocity time graph gives the acceleration. And in the acceleration time graph, you will see a straight line. Now the value of the straight line is not 0. It is a certain value according to the scale we have on the y-axis. But it means the acceleration does have a certain positive value in this case. So please understand these graphs. These are very important. Okay. Right, so we now go to understand there's an equation. This is a very important equation, and these are some symbols that you will be using throughout this chapter. So for displacement, you're using S. For initial velocity, you're using U. For final velocity, you're using V. For acceleration, A, and T for time. So in some books, for example, initial velocity is represented as VI and final velocity is represented as VF. So this book is using U and V. This is you might have studied previously before in O levels or in FSC, whatever you were studying. So you might have studied VI and VF. So it's the same. So if you combine these, you can get various equations, and one of these equations is the final velocity is equal to the initial velocity plus the product of acceleration and time. So this can be also written as VF is equal to VI plus AT. So these are known as equations of motion. They're useful in solving problems related to motion. Okay, now this is a graph of velocity and time, for example, and you can see in this case that the graph is going downwards. If the graph is going downwards, it means that negative, the velocity is decreasing with time. So you can see this is the negative x-axis. So the axes are like this. So this is x-axis, this is y-axis, you know, this is minus x-axis, and this is minus y-axis. So you can see it's going downwards. Okay, so you can try to understand these and practice these. Now let's talk about vectors again. Now we talked about the fact that last time we can represent a vector with a line, and make a geometrical construction with the, and we have to draw it like a graph, so which means it's according to a certain scale. So this is a graph paper on which this is drawn. So you can see this is the starting position, and this is the finishing position of somebody who's walking, and you can see that the directions are represented in terms of north, south, east, and west. So this person first walked north, then he walked for a certain distance, 4 kilometers. So these are 4 squares. And after that, he turned towards the east and walked 6 kilometers. Then he turned towards the south, and he walked for 10 kilometers. And now in order to find the addition of these vectors, for example, if you want to find the total displacement covered by this person, what you do is you use the, one of the ways to do this is to use the head to tail method or head to tail rule, which means you join the vectors one after the other, and then you join the tail of you know, this is the head of the last one to the tail of the first one. Okay, so in this order you can find the displacement, for example. So displacement is a straight line distance from the start of the first track to the finish of the third track. So this is known as the head to tail rule. The head, and then this is with the tail, and then the head with the tail, and then the head with the tail, and then the final result is of addition would be you take the tail of the first and join it with the head of the last. So a very important, again, you have studied this in school. You know your trigonometric ratios, right? So you know about the ratio of sine, which is opposite side over hypotenuse, cosine, and the tangent. Instead of opposite side, you can also write this is equal to opposite side in some books, or you might have read this as perpendicular divided by hypotenuse. It's the same. I'm giving you the different you know, terms that are used so that you can understand them and relate them. Adjacent side over hypotenuse. Adjacent side is also known as the base in some cases over hypotenuse. And then opposite over adjacent means perpendicular over base. So this is all referring to the right angled triangle that we have. In this case, one angle is a right angle, the other angle is theta. So the opposite side is this side, which you can also call the perpendicular, and the adjacent side is this, which can also be called the base. Adjacent means adjacent to the angle theta. Opposite means opposite to the angle theta. And this, the third line is known as the hypotenuse. Okay. Can you see the book?
Yes, ma'am.
Good. Okay, so this was the triangle we were talking about, and this was the angle theta here, for example, and this line, the opposite side is normally, if this is the capital A represents the point, the vertex of the triangle, and then small a represents the length of this line. Similarly, opposite to the vertex B, you have the line with the length B, small b, and opposite to the vertex capital C, you have a line with the length small c. Okay. So again, when we are dealing with vectors, one way of determining the vector direction is using the north, south, east, west method. And the second way is to use angles and then apply trigonometric ratio. So for example, here you can see that you can also draw it in terms of angles and describe, because sometimes it's difficult to describe as north, south, east, where it can be making a certain angle. So you can either say it's making a certain angle with north or with south or whatever, or you can say it's making a certain angle up with the x, y, or coordinate system. So for example, a vector in this direction would be making a certain angle with the x-axis, right? So it can be described in both ways. So you can use these rules for the same rules for addition, subtraction, multiplication, and division. Vector addition, we just talked about head to tail rule. So you have two vectors, you draw them and then you join them head to tail, and then you get your resultant. Another way to do this is by using the trigonometric ratio. So in this case, for example, if you have the lines like we said before, we have this is A, this is B, and this is C, then we can use Pythagoras theorem, according to which c squared is equal to a squared plus b squared, or c is equal to a squared plus b squared under the root. So you can use it. And then the angle theta, in order to find the angle theta, we can use the tangent formula. Tangent theta is equal to a over v, and therefore theta is equal to tangent inverse this is tangent inverse a over b. Okay, negative vector. If you want to represent a negative vector, what do? A negative vector is a vector that has the same length but it's opposite in direction. So you will see, for example, if you have a vector b in this case, then minus b will be the same length and but opposite in direction. So this is downwards towards the south, then the minus b will be upwards towards the north. Okay, so if you want to do a minus b, you will, instead of drawing b, you will draw minus b, and then you will follow the same head to tail rule. So these are, please practice these. And then we have the concept of components of a vector, the rectangular component. This is another method of solving vector problems. So a vector, for example, if you have a vector C, you can divide it into components. So if, again, you can use the x, y, z axis as your coordinate system, and you have a certain vector, let's say C, then it will, you drop a line on the x-axis, and this will be the x component, and you draw a line on the y-axis, and this will be the y component. Sorry, this will be cy. This one will be cy, and this one will be cx. So similarly here you can see this is cx and this is cy. The x component and the y component. How do you find the x component and the y component? Using the right hand rule, the trigonometric ratios that we have. You can see, you can use the sine factor to determine the y component. You can use the cosine factor to determine the x component, and then you can also determine the angle theta by using this tangent ratio, and then you can find the magnitude using the equation I just told you. C squared is equal to a squared plus b squared under the root. So if it is cx and cy, then you can use this. This is a very good and important theorem, which is known as the Pythagoras theorem. Okay, so we can solve one here. So I would like you, again, I'll give you a point. I would like you to tell me the x component of A2 and the y component of A2. So please tell, I give you 1 minute, solve it, and then tell me your name, and then we can discuss it. Yes. What are the x and y components of these vectors? I'm just asking you to do it for the vector A2. The vector A, sorry, it's not A2, it's A. This is the vector A. So 2 centimeter is the length of the vector, okay? AX is equal to what and AY is equal to what? Yes. Who will answer this question? Yes. Who would like to answer this? Come on. Yes. Halima, will you like to answer this? Halima? Hello, Halima. Are you there? Because if you don't speak, it means you're just logged in. You're not there in the class.
No, ma'am, we are.
Okay. So if I call out your name, so you should tell me something about it. Yes, Halima. Now, I'm not sure if Halima is in the class actually. Maybe she just logged in and then went away. Okay. अब क्लास में से कौन गया? अब नो नो निम्रा चली गई. Nimra is not in the class anymore. Okay, Mahnoor, would you like to answer this? Hello, Mahnoor, are you there?
Yes, ma'am.
जी बेटा, बताओ मैंने जो पूछा.
मैम मुझे समझ नहीं आया.
बेटा आप सुन रहे हो मैं जो बोल रही हूँ? मैंने जो बोला है वही पूछा है.
Yes, ma'am.
तो फिर बताओ ax कंपोनेंट कैसे निकालते हैं? What is ax? आपने लास्ट टाइम फिजिक्स कब पढ़ी थी?
मैम मैट्रिक में.
हाँ तो मैट्रिक में था ना ये. लेकिन मैट्रिक में वो चलो ठीक है, उसको टाइम गुजर गया, पर लेकिन अभी आज मैंने समझाया तो आप सुन रही थी?
यस मैम सुन रही थी.
तो फिर बताओ आप कैसे. ax का क्या मतलब है? व्हाट इज ax? ax मींस ओके. साउल रफाकत आप बताओ. ये तो फिर इस
मैम
यस
इसका कोई फॉर्मूला होगा जिससे वो ड्राइव
साउल
होता
अभी तो
है?
बात की है हमने फॉर्मूला की. कौन सा फॉर्मूला? ये ऊपर ये cx कैसे निकाला? साइन और कोसाइन.
कोसाइन से
हाँ ठीक है, राइट. ओके, सो दिस इज a cos कितना 30.
यस मैम.
तो a कितना है 2 मल्टीप्लाई बाय कोसाइन ऑफ 30 कितना होता है वो आप निकाल लें कैलकुलेटर से. उसकी वैल्यू डालें और ये आपका आंसर आ जाता है ax का। और ay कैसे निकालेंगे साउल?
मैम इसका ही वो दूसरा वो साइन से।
वेरी गुड, सो साउल गेट्स अ पॉइंट। ओके, सो इसी तरीके से आपने 2 मल्टीप्लाई बाय साइन ऑफ 30, उसकी वैल्यू आप कैलकुलेटर से देखें और यू कैन मल्टीप्लाई इट एंड यू कैन गेट योर आंसर। ठीक है, सो दिस इज, इसका क्या मतलब क्या होता है कि ये जो a है इसका ये a component along the x-axis, that is ax, and the component along the y-axis is ay. So Saul gets the point here. Okay, good. So you need to practice these concepts. As I can remind you that we do have your assessments coming up. Are you preparing for those assessments? When is your assessment due?
30 April.
30th of April.
Yes, 30th of April. So you have to prepare this for 30th of April. So which chapter are you preparing for 30th of April?
Chapter 3.
Yes, and then you have to prepare the quiz. And which chapter do you have in the quiz?
From third and fourth.
3 and 4.
3 and 4. So please remember this. Okay. So this is chapter 3. This is chapter 3 and 4. Okay.
Ma'am, I have one thing, that experiment 3 and 4 का जो link है वो work नहीं कर रहा था when I tried it.
Okay, I'll check it. Okay. Experiment.
Yes, ma'am.
बाकी लोगों ने check किए?
Yes, ma'am.
वो link बाकियों का काम किया?
मैम मेरा भी नहीं था कर रहा, मैंने वो क्लिक किया था लेकिन उसमें आगे जाके लोड पे 404 एरर आ रहा था।
Experiment 3 and 4 भरा क्या है? It's about
Ma'am, pendulum.
mass and amplitude of a pendulum, है ना?
Yes, ma'am.
Yes, ma'am.
अच्छा ठीक है।
मैम थर्ड था सिंपल पेंडुलम था।
हाँ, mass और amplitude दो थे ना, एक 3 था एक 4 था, ठीक है?
Yes, ma'am.
Okay, so we will check that. So we come back to where we were.
और मैम कोई एक क्लास रख के लैब का भी थोड़ा सा बता दें, क्योंकि वो कभी कभी चलती है, कभी समझ नहीं आती करना कैसे उसको।
बेटा उसका वीडियो भी है, उसका डेमो भी है और उसकी एक्सप्लेनेशन स्लाइड में होती है। इट्स सो सिंपल। Okay, I'm trying to share this. Okay. Right. Okay, so here you can see how we can use this method of components to add vectors. Okay. And in this case, you can see how this vector, for example, we have two vectors. One is A, it's making a certain angle theta with the x-axis. We have B, it's making a certain angle phi with the x-axis. You can see this is above the x-axis, this is below the x-axis. And if you want to add these using the method of components of vectors, you draw the vectors like this together, okay, by the head to tail rule, okay, but then you also divide them into x and y components. So the perpendicular here, this is ax and this is ay, along x-axis is ax, along y-axis is ay. You now have a right angle triangle. But remember that the standard right angle triangle that we had previously. Okay, so we had like this. This was theta, this was the opposite side, okay, and this was the adjacent side, and this is the hypotenuse. In this triangle, you will see that theta has come here, so the opposite side will be this one. And the triangle has rotated, okay, and the adjacent side will be this one, and this is the hypotenuse when you want to apply the trigonometric ratios or you want to apply the form of Pythagoras theorem. So you remember this. Also, this triangle is rotated. You will see this is angle phi. Again, the opposite side, this one, this will be the A, and this will be B, and this will be C. So remember this when you're applying your formula. So in this case, what I showed you before in this here, when I showed you A, B, C, yeah, I've been showing you in different diagrams. You see, like this, A, B, and C. You can use all these formulas. And when we talked in the beginning about the trigonometric formulas, we can also write them in form of A over C, B over C, A over B. But then you have to also determine, according to the diagram that you are working on, which one is A, which one is B, and which one is C. Okay, so in this one, you can then find the resultant. You can use this method of addition of vectors. In order to add the vectors, you will see that the resultant is C, okay? But then you can add the x components of A and B to get the x component of C. And similarly, you can remember some of them are capital, the ones in the trigonometric ratios are small, don't mix them up. So similarly, you add the y components of the vector to get the y component of the resultant C. In some books, the resultant is written as capital R. So in this book, we are using the symbol C. Again, when you have Cx and Cy, then you can find the length of C by using the Pythagoras theorem, which was C squared is equal to A squared plus B squared. But in this case, we're using Cx squared plus Cy squared. And also the angle, we used tan theta is equal to A over B. In this case, we already have theta, we already have phi, so the angle for C has been represented by another symbol. We need a different symbol now, and this is psi. So psi is equal to Cy over Cx, because if you look at this triangle, the triangle for the vector C, you will see the opposite side is Cy and the adjacent side is Cx. So using these, you can then find the values and fill your answer. The x component of A is equal to this, the y component of A is equal to this, just like we found in the previous problem that we solved. Okay, you do the same for B, you do the same for C, and you get your answers. Okay, so this was, go and practice this again and you will understand how this was worked out. Okay, so this is a method of adding vectors. Okay, so here you have an example that is using this same method. So please go through this and solve it yourselves to understand how it's working. Okay.
Yes, ma'am.
So please study regularly, okay? Now this is again, there's a very important relationship between force, mass, and acceleration. What's that relationship? Can you remember? Okay, let's talk about Newton's first law. Newton's first law is known as the law of inertia, right? Inertia means, you're familiar with this. The inability of a body to change its state of rest or its state of motion. So according to Newton's first law, a body that is at rest will continue to be in a state of rest, and a body that's in constant motion will continue its constant motion until an external force is applied to that body. Okay, so that's first law. And then Newton's second law is the relationship between force, mass, and acceleration. So force is equal to ma, F is equal to ma, or A is equal to F over m. So whenever you apply a force on a body, it will, of mass m, it will move with a certain acceleration. This is our everyday experience. When you push a ball with a certain force, the ball will start moving, right? When you apply a force on a bicycle, the bicycle will start moving. So it depends. Okay, so please practice these concepts. They're important. Okay. And for the lab link, I will update you about the lab link, but do the other labs. Okay, you have all the material you need. You have all the lab manuals, plus you have the slides related to each of these labs, and you also have the video demonstrations of how this is done. So just go to the link and practice and play with it. It's just like a game. You just change different values and you will see what's happening. Okay. So this is the end of our meeting, okay?
Yes, ma'am.
So please practice after class, practice for at least 1 hour after every class so that you you don't have to then feel a burden for your assessments. Okay, if you practice 1 hour after every class, you'll be fine. Okay.